Okay, welcome to today's scope. Sorry for those people that tuned in about 5 seconds ago. I started this without Okay, welcome. My name is Joe. I'm the physics program chair at Cabrillo College, and it's going to be a real quick scope because the semester starts tomorrow. But what I want to do is show you a pretty cool demo with physics. So I'm going to turn this camera around. Okay, what we have here is a laser, and what I want to show you is, turn this around. If you can see across the wall there is a little dot. That's you lonely. No, I'm not lonely. I'm just stressed trying to get ready for the semester. Hey, I see it. So if you can see that red dot, that's where the laser is hitting the wall. Question I want to ask everybody before I show this demo is, I am at Aptos. How come you can't see the laser until it hits the wall? Anybody have a guess? How come you can't see the laser until it hits the wall? Hey there, M. Leffler, committed to scoping. I am. Tell you the truth, I really didn't want to get on today. I'm going to be up till the wee hours of the morning, but I made a commitment to get on here every single day. Nothing for the light to reflect off of. Outstanding, that is correct. So in order for us to see light either has to enter our eye directly from the source or it has to be reflected off an object. Right now you can see that little dot because it's getting reflected off the wall. However, you can't see the path of the laser because the air is not dense enough to reflect much of the light. So what I'm going to do is get some fantasy effects. I love this. It says, one can lasts all night. And what I'm going to do is spray this. It's basically fog. And when I spray the fog, what you're going to see, what it's doing in essence, it's like making the air thicker. And the thicker the air is, the more molecules and atoms there are to reflect the light. So what I'm going to do is dim the light a little bit, spray some fantasy effects fog, and you should be able to see the laser. Hold on for 10 seconds while what grade am I teaching? I teach college physics at a community college in Santa Cruz. So I teach the first 2 years of physics you would take at a university. So let me dim the lights. All right, so hopefully you will now be able to see the path of the laser. Are we able to see it here? Tell you what, I'm going to turn the light off and I'm going to have the laser reflect off of a mirror. So hold on 1 second. Ooh, now you can see it pretty sweet. So check this out. I'm going to have it reflect off a mirror. And this is a corner reflector. So now you should be able to get a pretty cool path of the laser. Check it out. Now this only works because I'm using fog, which in essence is making the air a bit thicker. And the only reason you can see this laser beam is because it's reflecting off of some of the smoke. Some of it is reflecting back towards the iPhone. So now you can see it. And what I have here is called a corner reflector. Oops, in the path of the beam. Corner reflector is 2 mirrors at right angles. So what happens is the laser light hits, reflects off the mirror, and comes back. I want a laser beam. Yes, lasers are awesome. And a pretty cool fact, they actually have a corner reflector on the moon. And one of the ways that we can measure the distance to the moon is by actually shooting a laser to the moon, having it reflect off the corner reflector, and measuring how long it takes from when we send the laser to when we get it back. What happens when you point a laser into a prism? Do you know what? I wonder if I have a prism handy. I will show you that demo sometime in the near future. Make sure you give this guy some hearts. Thank you so much. So again, the reason you can see this is because I used some fog, basically. And what that's doing is it's making the air thicker. The thicker the air is, the more chance the laser beam has to reflect off of atoms and molecules. And the only way for you to see it is if that light reflects off of something and then comes back towards your eye, or in this case, the iPhone. So let me turn the light back on. Let me turn this around for a second. Okay, so hope you enjoyed that. My name is Joe McCullough. Ooh, too much light. Physics program chair here at Cabrillo. Will it work with a laser pointer? You know what? Only one way to tell. Let's go actually get a laser pointer. Let me just give you a little quick view of the stock room. A stock room here at Cabrillo College. Let's find a diode laser. Let's find a nice laser pointer. Got a purple one. Let's try these. Turn this back. The laser pointers, we're going to try it again with a laser pointer. All right, I'm going to flip this back around. Okay, so I've got, this is a violet laser. I don't know how well you can see it. No. Okay, so here's a violet laser. You can't see it very well. Let's see. Hold on one second, I have to dim the lights again. All right, hold on one sec, coming back, don't lose. Okay, so right now I have a laser pointer. You can kind of see it's hitting my hand. This is not a strong laser, so I don't have to worry about getting hurt. But notice you cannot see the path of the laser until it hits my hand. The reason is once it hits my hand, it reflects back, and you're seeing the light that reflects back towards the camera of the iPhone. So let me see now if I can spray some smoke. And the answer is you can see it a little bit, but this is a very dim laser, so you cannot. Okay, today was just a real quick short scope, because I have the semester starting tomorrow and I am stressed, but I made a commitment to get on here every day. So what I want to do real quick before I go off, I teach 5th and 6th grade science. Yes, you could see it. So I want to give you a quick little schedule. Since I am scoping every single day, I want to let you know what you can look forward to. So Monday, I was doing a 5-part series on how to make your message memorable. My obsession is the brain and how people learn. We're watching you daily. Thank you, ETF Doc. The good doctor deserves way more. Thank you, Wayne. I've checked out your scopes. They're awesome. So Monday, going to talk a little bit about the brain. 5 brain facts that all speakers, teachers should know to make sure that their message gets remembered. And then Tuesday through Thursday, I'm going to show you some awesome physics demos. And then Friday and Saturday, I'm in Vegas. I don't know what I'm going to scope about. I may just show you some pretty cool scopes. So high school or college, I teach college physics at Cabrillo College in Santa Cruz, California. For those of you who don't know me, my name is Dr. Joe McCullough. I'm the physics department chair at Cabrillo College, and I'm on here every single day. Emotions equals memories. That was one of the big tips. Another big one is that we store visual, auditory, and kinesthetic memories in different parts of the brain. So if you want your message to stick, you need to make sure you use different learning modalities. What goes on in Vegas? Yeah, I won't be scoping about anything inappropriate. Like your scopes. Thank you so much. One more time, this is what you can look forward to. If you're not following me already, please swipe from left to right on an iPhone or straight up and hit follow. Great content, Doc. Thank you. So one more time, Monday, tomorrow, I'm finishing my 5-part series on how to make your message memorable, given what we know about the brain and how people process and store information. And Tuesday through Thursday, I'm going to show you some pretty cool physics demos. One of them, I'm going to make time freeze, matrix style, and show you a pretty cool electricity demo. And then Friday and Saturday, I am in Vegas. That's it right now. Yeah, for demos, yes. And quick tip, if you are a speaker, as much hands-on activities you can do, I use demos all the time because we are visual learners. And the more visual things you can use, the better it is. Thank you, thank you, thank you, everybody. Can we blow some shit up? No, but one of the demos I'm going to show you probably this week is how you can use the air around us to crush an aluminum can. Pretty amazing how much force and pressure the air around us exerts. We don't notice it just because we're living in it. It's just like a fish doesn't notice that it's in the ocean. We've adapted to the incredible amount of pressure the atmosphere exerts on us, but I'll show you how you can crush a can using just the atmosphere, and you can do it at home. Very simple demo. Okay, that's it for today. Thank you so much for watching, and I will see you tomorrow.